This is Integrated Math 1's Practice Test 7. I'm Mr. Sindel. In number 1, we are asked to find some systems of equations that are both consistent and independent. Consistent means that there is at least a solution, and independent means there's exactly one solution. I noticed that we are given this graph right here. In terms of a graph, independent means that there's only one solution. There's only one intersection. So, for example, if I have these two lines, there's exactly one intersection. So, luckily, they're all labeled for us. It's nice and easy. So, y equals 2x plus 1 is right there. Therefore, this line, this line right here is the line it's talking about. And this y plus 2 is equal to 2x is this one right here. So these are the two lines that are being given to us. These ones are inconsistent. They never cross. So you don't have to label these, but I'm going to just so you can remember that these are inconsistent. What about b? Y equals 2x plus 1 is u. Y equals 3 is u. So I have this line and this line. Notice there's exactly one intersection. That is one of the solutions that we were looking for. What about the next one? Y equals 3 is this line right here. X equals negative 2 is this line right here. Notice there's exactly one intersection, which means that is also an answer. Did not mean to do that. Let's see, x is equal to 2 is this line right here. And then I have y plus 2 is equal to 2x is this line right here. Notice that there's exactly one intersection. This is also an answer. X equals negative 2 is this line right here. X equals positive 2 is this line right here. Those are parallel. They will never intersect. Those are inconsistent as well. Let me go ahead and label those. This one is inconsistent. There is no solution. They never cross. All right. In number 2, consider the system of equations. How many solutions are there? Okay, this one is not even asking us to solve it. That would be harder. It just wants to know how many solutions are there and whether or not they're dependent or independent. So the way that we're going to first tell if there's solutions is we're going to write these both in y equals mx plus b form. This equation is ready to go. This equation is not. So let me go ahead and rewrite that over here. I have 8x plus 2y is equal to 8. And I'm going to solve for y. So I'm going to move the 8x over. I don't want to divide by 8x because that's going to leave a remainder of 1. I want to move the entire 8x over, so I'm going to subtract 8x on both sides. Subtracting 8x, subtracting 8x. And that means that that is gone, leaving behind a 2y, which is equal to an 8 minus an 8x. The next step that I'm going to do is to get rid of this 2. I can divide both sides by 2. When I do that, I divide by 2, divide that entire side by 2, but my shortcut is to divide each individual term by 2. So I'm going to go like this, divide by 2, divide by 2. That's the same thing. So now I have y is equal to 4 minus 4x. And I know this is not slope-intercept form, it's intercept-slope form, but it's good enough. I mean, if you really want to, you can rewrite this and say it's really y is equal to negative 4x with a positive 4. Again, there was a plus hidden in between the 4, and then I have this negative 4x right here. Everything's looking good. So I'm noticing that when I write this one up here, it's the same exact equation. Look at that. There's y, negative 4x, plus 4, plus 4. So these systems are, there's an infinite number of solutions for this one because they are the exact same line. The lines are on top of one another. So you want to say here, there's an infinite number of solutions. And then the next question is the system dependent or independent? Independent means that there's one solution. Dependent means that they are the same solution. And that means that we are dependent in this case. All right. Number 3, which system of equations can be entered into a graphing calculator to solve these things? So this is from lesson 7-1. Just remember that if I have something complicated equal to something complicated, and this is a life lesson kind of when you, well, not really a life lesson, it's like a lesson for higher level math. If you have some sort of like crazy function, like an exponential function over here, and that's equal to some sort of weird polynomial that's happening over here, you can set this equation equal to y, this equation equal to y, and see where they intersect. So I'm going to say y equals this thing, find where they intersect, and you can see y is equal to that thing, y is equal to that thing, and the correct answer here is B. And number 4, we actually want to solve this one. It says solve this using a graphing calculator. So the graphing calculator that we use is the Desmos graphing calculator. So if I have my first equation, which is going to be y is equal to 6.9x plus 4.3. My next equation is going to be y is equal to 4.7x plus 8. and I want to find where these intersect. And on my graph, it's up here. If I just touch that with my finger, it says, it has the x-coordinate 1.68 and the y-coordinate 15.9. I mean, immediately, 15.9 isn't an answer, and I want to explain why. Haha, pun intended. The y-coordinate is not going to come up here because in this equation, there is no y variable. There's only an x variable. So we're really looking for the x variable. And if I round the x variable over here on the graph, it's 1.68, and 1.68 is indeed the answer. Go ahead and circle B, and we're done with the graphing calculator. Let's hide you away. In number 5, we have Talon selling plastic and wooden frames. This one is a little bit tricky. Usually with word problems, especially when we're dealing with a system of linear equations, I typically start at the very end, say, how many of each type of frame did Talon sell? Okay, so that means that my final answer will have a frame of each type. So I'll have one variable for one frame, one variable for the other type of frame. So I need to scan this question. What are the two different types of frames? Oh, we go to the first sentence. We got plastic and we've got wooden. So maybe I'll do P for plastic, W for wooden. That'll make a lot of sense. So let me define my variables. I'll say P is going to be number of plastic frames, and we'll say W is the number of wooden frames. Now we have some variables, now we need to make some equations, and typically speaking, this is the unit for a system of linear equations, meaning there are at least two equations. So I'm reading this first line, or I guess the second sentence. He sold 7 frames. That is an equation. A little bit tricky, but total frames means a mixture of plastic and wooden. If I added those together, that is the total number of frames. So if I add P and I add W, if I add the plastic and I add the wooden, I should equal 7. It's a little bit tricky to see that, but we do want to write that down. So P plus W, the total number of frames, this represents the total number of frames is equal to 7. The next one is a more literal equation where you can just kind of write down what you see with a few exceptions. So the number of plastic frames, oh look, number of plastic frames, that is exactly the same thing. So this entire these words right here, you can cross all of that off and just change that for the word, or the letter P. So I'm going to say P, okay? Whenever you see was or is going to be, any sort of conjugation of, I was going to say ir in Spanish, but any conjugation of the is, past tense or future tense or present tense, that always means equal to sign. So I'm going to cross off the was. This always means an equal to sign. So now I am saying P equals, so P equals, and then 5 less than. Okay, 5 less than is a really tricky one for most students because it means do something and then after you're done with it, then subtract 5. So I'm going to give some space right here, and then I'm going to subtract 5. This means 5 less than whatever it's going to talk about next. So I've got the 5 less than, and then here's the twice the number of wooden frames. Well, the number of wooden frames is just W. So this says twice of W, or 2 times W. So I have 2 times W in here, and I can go ahead and erase stuff and move things around, and I have 2 equations. First equation, second equation. Notice this is referencing 7-2, which was the lesson where we learned substitution. And indeed, substitution is the easiest way to solve this system of linear equations because we have a variable that is solved for. Notice the variables don't line up. There's no W underneath here. If the variables did line up, I would be more inclined to use elimination. This one I want to use substitution. So let's do that. If this P is 2W minus 5, this P right here is also 2W minus 5. So I'm going to show my work by circling my 2W minus 5, doing an arrow and saying I'm plugging that into P. So here it is. It's 2W minus 5. I have now rewritten P. Now I'm going to write this plus sign. Now I want to change my color so it's very clear what I'm doing. Plus sign. I'm going to write the W equals 7. W equals 7. I have rewritten this equation, but I have substituted in my P. And now in this equation, notice I have one equation with one type of variable, which means I can solve this. If I have one equation with 2 variables, you can't really do anything. So from here, the parentheses are always needed, but in this case, you don't have to use them because if I have a plus sign, there's no distribution that is happening here. You can kind of ignore them. You can say, okay, I have 2W here, a positive W there for a total of 3W, and I still have my minus 5, and that's equal to 7. Let's go ahead and add 5. We get 3W is equal to 12. I'm running out of room, so let's come and work up here. So if I have 3W is equal to 12, the next step is to divide by 3, and W is equal to 4. I'm not done because it asked how many of each type. I don't just want wooden frames, I want each type. So I need to either use this equation or this equation. This equation is harder to use for W because I have to do multiplication. This one is just adding and subtracting. So I kind of want to use that one. You could plug it into either one though. So let's go ahead and plug it into this one. Now I'm going to say P plus W is equal to 7. Look, I've rewritten this entire equation, but variables are just boxes that you can plug numbers into. So this is the box that holds W, and this 4 is going to be plugged in here. Let me go ahead and write that in here. This 4 is going to go right here, and now my equation is P plus 4 is equal to 7, and I will subtract 4 from both sides, subtract 4 from both sides, and P is equal to 3, which makes sense. So if 4 and 3 are the numbers, 4 plus 3 is 7, and if I just check my work, right, 4 is W, so 2 times 4 is 8, and 8 minus 5 is 3, so this entire side is 3, P is equal to 3. That makes sense. So whenever you have a word problem, typically speaking, you will write your answer as words. If you just say P is equal to 3 and W is equal to 4, that's not okay unless I guess you've defined it up here. I defined it, so I guess I'm okay. I want to show you guys how I would do this. I would write out my answer and say there are 3 plastic frames and 4 wooden frames, and box that word, which is a word answer to a word problem. And number 6, we need to consider these equations. What is the solution? I'm noticing in this one, it is still referencing 7-2, but I'm noticing that I don't want to do substitution because my variables line up. My x's are there, my y's are there, my numbers are there. I can literally just add these together and nothing is going to happen because I'll have to get 4x and a negative y. I need to multiply one of these equations by something in order to use elimination. I see that I have a negative here and a positive here, so I'm inclined to try to eliminate my y's. So I need to make this number in front of the y be the same as this number. So if I multiply this entire equation by 2, the coefficients should match up also. Multiply by 2, multiply by 2. This new equation, I'm going to write it up here, is going to be 2x plus 2y is equal to 20. And now check out these two equations that I've written here. The plus 2y and the minus 2y will cancel out if I add them. So let's go ahead and add them now. So if I add them together, I'll write my answer over here. I'm going to say my 2x plus 3x is a 5x. My 2y minus 2y cancel out. I have my equal to sign. And I have 20 plus 0, which is just 20. And now this is a really easy equation to solve. I can just divide both sides by 5, divide by 5, divide by 5, and x is equal to 4. We're halfway there, but I'm noticing there's only 4 choices. Is the x-coordinate 20? Is the x-coordinate 3? Is the x-coordinate 4? Or is the x-coordinate 6? The x-coordinate is 4, so I think I'm done. But I mean, if I wanted to really prove that this is 6, I could go a step further, but it's multiple choice. Go ahead and feel okay with that. I'm going to plug into the x plus y here. Let me leave a spot for x. X plus y is equal to 10. I'm using this equation right here before I multiplied 2 on both sides, and I'm going to plug 4 in right here. So this 4 is going to be plugged in right here, and then I'm going to subtract 4, and y is equal to 6, which is indeed this y coordinate here. All right, moving on to number 7. So we need to determine if the system has no solution, one solution, or infinitely many solutions. So there's a bunch of ways that you could go about this, but generally speaking, if you take a look at the x and y numbers, if they both match up exactly, then that means there's going to be either infinite or no solution. One solution is when x's and y's don't match up. And if the system has one solution, name it. We might as well just try to solve this one. This is still referencing lesson 7-2. We could do substitution here. I really prefer elimination, especially when my variables line up. So I am going to be using that method. I'm going to, all of these are positive. So I'm going to have to multiply one of them by a negative. The lowest number is 2. So let's go ahead and make this y a negative 2. Again, you don't have to do the y's. I realized the last case I also eliminated the y's, but they happen to be easier on the last 2 problems. I could eliminate the x's if I wanted to. I'll get the same answer, but I don't really want to. I want to make this as easy as possible. So and we'll multiply this entire side by negative 2 with the expectation that negative 2 times y is a negative 2y, and that will cancel out with this positive 2y. Anything that I do to the left, I also have to do to the right, so I also have to multiply by -2 over here. And I get a new equation, which I'm going to write underneath here. I'm going to get a -2x from distributing and a -2y from distributing. -2 times 5 is a -10. And now these are the two equations that when I add together, I should eliminate my y's. Indeed, I do eliminate the y's. 3x minus 2x is a simple x, and 8 minus 10 is a -2. From here, I can plug back into anything that I want. This original equation was pretty straightforward. It was x plus y is equal to 5, and I can plug back in a -2 for my x. So -2 goes in here, and I can now get rid of it, add 2 to get y is equal to 7. So my solution is -2 comma 7, and that's one solution. Notice the question originally asked, what type? Is it no solution? No, it's one. It's one solution, and it says if the system has one solution, which it does, name it. It's named -2, 7. I just like going back and re-asking the question to make sure I've answered the question correctly. Number 8. So I have the sum of measures of two complementary angles is 90 degrees. That's actually the definition of complementary. Whenever you see the word complementary in the wild, it always means two things. It actually doesn't mean two things. It could mean 3 or 4 things. It just means when you add them up, they'll always be 90. So when you add things together, they're 90. Good to know. Angles P and Q are complementary, which we already said they're complementary. And the measure of angle P is, 6 degrees more than twice the measure of angle Q. That sounds a little bit tricky. We'll come back to you. We need a system of equations and find the angles of P and Q. And it's specifically telling us use substitution. We're forced to use substitution. We can't use elimination, which is my personal favorite method on solving a system of linear equations. So I need to set up two equations. The first thing I'm going to say is they sum, meaning they add up to 90. So if I want to say they add up to 90, this angle and this angle added together are 90. So my first equation is P plus Q adds up to 90. That's what it means to say that the sum is 90. And then from there, I want to say the measure of angle P. So I'm just going to say P. The measure of angle P is, again, whenever you see the word is, past, present, or future tense, that always means an equal to sign. So now, equal to sign, 6 degrees more than, which means I'm going to do something, and then I'm going to add 6 to it. So I'm going to give some room for my something, and then I'm going to add 6 to it. Just like the word less than used to mean do something and then -6. More than means do something and then add the 6. So 6 degrees more than, what's the thing that goes in here? Twice the measure of angle Q. Twice always means times 2. So times 2 the Q. That's what goes in this box right here. Times 2 the Q. So my second equation is 2Q plus 6, which makes sense when I read the question again. 6 degrees more than, 6 degrees more than twice of Q, twice of Q. Okay. I have my system of linear equations. I would have been inclined to use substitution even if it didn't tell me to, because one of these equations has been solved for a variable. So again, I always point out the way that I do my substitution. If this P is 2Q plus 6, this P must also be 2Q plus 6. So I'm going to rewrite this equation, but in the place of this P, I'm going to substitute 2Q plus 6. So here I go. This 2Q plus 6 is being substituted in for the P. So I now have 2Q plus 6. I have just rewritten P, and I'm going to write the plus Q, and I'm going to write my equal to 90. Equal to 90. I've now rewritten this entire first line while doing my substitution. Notice I have one equation with only one type of variable. There's no Q's and P's, it's just Q's. So notice the instruction said, write a system of equations, which we did, and then we're going to solve, which we are doing now. Okay, so from here I have 2Q plus Q, adding my like terms, that adds up to a total of 3Q. And I still have this plus 6, which I'm going to rewrite. Plus 6 is going to be equal to 90. And from here, I'm going to subtract 6 on both sides. Subtract 6 on both sides, and I get 3Q is equal to 84. From here, I need to divide both sides by 3. Divide by 3, so Q is equal to a number. If you don't like doing 84 divided by 3 in your head, you can always use a calculator. I'm okay with that. And we have the multiplication tables up front as well. I like doing this the hard way, though. So I always think, okay, what number is really close to 84 that is also divisible by 3? I happen to know that 60 is divisible by 3. Also 90 is divisible by 3. I think 90 is a little bit closer, so that's one I want to use. I'm going to say that this is the same thing as 90 over 3, but 90 is not 84. They can't be equal to each other. I have to do something to the 90. If I go down 6, I'll get here. So I can say minus the 6, and to keep like denominators, I'll say 3. So 90 thirds minus 6 thirds is the same thing as 84 thirds. I hope you can nod your head and agree with me. And I can simplify this because 9 divided by 3 is 3 with the 0. So I have 3, 0, 3, 0. And 6 divided by 3 is 2, so minus the 2. And hey, 30 minus 2 is 28, so Q is equal to 28. Notice I'm not done because it didn't say just find the angle of Q. It said find the measure of angle P and Q. So I have Q, and I need to find P. And I'm going to use the most basic equation. This one up here doesn't have any multiplication in it. You could plug it into either one. You could plug it in there or there, but I want to use the easier one. So I'm going to rewrite that equation. This says P plus Q is equal to 90. And in the place of Q, you know we're going to be doing some more substitution. This 28 is Q, so I'm going to plug that in right here. So I'm going to say 28, and then I'm going to solve that. So I just need to subtract 28 on both sides, subtract 28, subtract 28. And P, therefore, is equal to 62. And just doing some mental math, 2 plus 8 is 10. Carry the 1, so this turns into a 3. 3 plus 6 is 9. 90. That makes sense because they should have added up to 90. Excellent. So I have my two angles. I should now box them. Q is that angle. P is that angle. And we move on to number 9. Number 9 says, solve the system of equations. I see that the lesson that it's referencing is a lesson where we learned basic elimination. And indeed, I see a positive y and a negative y on top of each other. My variables are lined up. My numbers are lined up, meaning it is ready for elimination. I already have opposites for my variable y. If I just add these together without doing anything, my y's should cancel out. Positive y and negative y are nothing. 3 plus a half is 3.5. So I have 3.5x, and that's going to be equal to 34 plus 1 is 35. I don't know about you, but I don't like decimals. I want to get rid of decimals. So I want to do something that maybe you don't enjoy doing. I know that a lot of students here would probably just be like, oh, just divide both sides by 3.5, divide by 3.5. And you could totally do that. But then you have a mixture of decimals and fractions. You could just use a calculator. I'm totally okay with that, but I want to challenge myself. How would I do this without a calculator as fast as possible? I would get rid of the decimal. I know a thing that will move the decimal here to get rid of the decimal. Moving the decimal just means multiplying by 10. So my hidden trick is multiply this side by 10, multiply this side by 10. I don't want to multiply that side by 10, but I'm forced to since I'm multiplying the left side by 10. Multiplying this left side by 10 moves the decimal over, and I now have a 35x is equal to 350. And now this is much easier. There's no more decimals. I can divide both sides by 35, divide both sides by 35, and x is equal to a number that I happen to know if I ignore the 0, 35 divided by 35 is 1, add the 0 is 10, aka 10. So again, I'm not done. I need to solve the system of linear equations, and I have x is equal to 10. I need to know what the y is. So you have a choice. You want to plug in the x there or there. Personally, I guess multiplying by 0.5 isn't too scary because it just means take half. Half of 10 is 5. But I know a lot of students are scared of decimals and fractions, so I'm guessing a lot of people are going to plug it into the one that doesn't have a decimal. I will do the same thing. So I'm going to use this equation. I'm going to rewrite it, but in the place of x, I'm going to write a 10. So here goes. I have 3x plus y is equal to 34. And then I'm going to plug in my 10 in for x. So there's my 10. And 3 times 10 is 30. Plus y is equal to 34. And then I can subtract 30 on both sides, subtract 30 on both sides, and y is equal to 4. So again, I have an xy combo, so 10 and then 4. You always do x first, y second. So it's going to be 10, comma, 4 as a coordinate pair for my final answer. All right, moving on to number 10. Ooh, multiple choice with a word problem. Let's go ahead and read. A rectangle is x inches wide. I already did that. And 3y inches long. Diagram is correct so far. The sum of the length and the width is 36 inches. That hasn't been added, so we probably need to write that down. Let's do that now. Sum means add. So add the length. Well, it says the length is 3y. So if I add 3y, so I'm going to just do 3y plus the sum of the length and width. So the width, it tells us that the width here is x, so I'm going to add x. So now this says the sum of the length and width, the sum of the length and width is. Whenever you see the word is, that always means an equal to sign, and then 36. 36. And, okay, so that probably means there's a new equation. The difference. So difference is a word that means subtract. So subtract what? The length. So the length is 3y because it says 3y is the length. Long and length go together because they both start with an L, right? So I'm going to do 3y for the length, 3y minus the difference between the length and then difference and twice the width. So I'm going to say twice the width. Again, x is the width, so twice the width is. Whenever you see the word is, it always means equal to sign, and the answer here is 12. So I'm going to write down the 12. Find the length and the width. Find x and, you have to say 3y is the width? That's interesting. This is... I don't like this problem because it's unclear. Am I solving for y or am I solving for 3y? Because it says the length is 3y. So we should be just solving for 3y. We might as well just not call that 3y and just call it z or something. I don't know why we have a random 3 in front of it. Maybe the question is actually solving for the y. We'll find out, right? This is referencing lesson 7-3 where we learn basic elimination. I'm noticing that my x's and my x's have opposite signs, so I could either eliminate my x's, but I also notice that my y's have the same number. I kind of am inclined to eliminate the y's in this case because I can just do, if I multiply this entire equation by a negative and just switch all the signs, this becomes negative, positive, and negative, then they'll be able to cancel out. So let's go ahead and do that. Which one do we want to multiply by negative? Let's multiply that one by negative. It doesn't really matter, right? Let's multiply this one by a negative. Say negative is being multiplied there and there on both sides. So negative times a 3y is a negative 3y. Negative times a positive x is a negative x. And negative times a 36 is a negative 36. So now notice that these two equations should have a y that cancels out. Let's go ahead and see what happens there. So let's add them together. So adding them together means that the y's are gone. Negative 2x and a negative x are going the same direction. I have a negative 3x, and it's going to be equal to, adding these together, that's going to be a negative 24. And I can divide both sides by negative 3, divide both sides by negative 3, so that x is equal to, okay, be careful here, negative divided by negative is a positive, 24 divided by 3 is an 8, so it's a positive 8. So when I'm looking at my multiple choice answers, I see one of them is 8, one of them 8. Those are not correct. So let's go ahead and cross off C, cross off D. It's between A and B. We have to figure out what is the actual length now. So which equation do we want to plug into? Do we want to plug this x equals 8 into that x, into that x, into that x? We can choose whichever one. I guess I can plug it into this x. I don't like the idea of multiplying by a negative 2. I feel like that might trip me up if I forget the negative. So let's plug it into this first equation. So when I do that, I have 3y plus x is equal to 36. I've rewritten the equation, and into the x goes an 8. So 8 goes right here, and I now can solve for y, I assume. So let's go ahead and subtract 8 on both sides. So subtract 8, and 3y is now equal to 28. So this is the time where we have to be very careful. What are we solving for? Are we solving for 3y or are we solving for y? It tells us that the length here is 3y inches long. So I have a feeling that that's what we were supposed to solve for, but I don't. If we divide this by 3, I'm imagining it turns into 9.3. Let's do that really quickly to see what would happen. I'm pretty sure we're done. I think that's the answer. I preemptively want to circle A, but just I'm curious, is the 9.3 coming from 28 divided by 3? So if I do that, 28 divided by 3 is the same thing as 27 divided by 3. Why did I do that? Well, I know that 27 is divisible by 3, but 27 is not 28. I need to add 1 to it. So it's plus 1, and they have to have like denominators. So these two are the exact same fraction. This first fraction is 9. This second fraction is 0.3 repeating. If you don't have that memorized, we should play the blueprint a little bit more. This is 0.3 repeating. And this is the same thing as 9.3 repeating. which looks like the right answer, although it doesn't have the bar above here. Technically, it should have a bar saying it goes forever and ever. This is an interpretation question. It's super duper tricky. I do not want to put one of these on the test because it is that tricky. This is saying that the length is 3y. We were supposed to solve for 3y, so I'm pretty sure 3y is 28. I know that's confusing a lot of students. They always say, well, aren't you always supposed to solve for y? No, this is the length, and that length is 3y. Therefore, you're solving for 3y, not y. I'm still going to go with A. I haven't looked at the back of the answer book. I'll look at the end of the video and then decide how stupid I was in the present tense right now. All right, number 11. Multi-select. Select all the ways that the system can be solved. Okay, so let's go ahead and see. Okay, variables are lined up, numbers are lined up. My first inclination is to do elimination. Let's read the multiple choice. Multiply the first equation by 4, and then add the equations. Okay, so if you multiply them by 4, this one is going to be, the 9 is going to turn into a 36. That's not going to help. This one's going to turn into a -8. Oh, if this one's a -8 and this one's a +8, that would eliminate. That would be a good check. Yeah, so I would say, yeah, that one works. Multiply the second equation by 3. So if I multiply the second equation by 3, this is going to turn this 3 into a 9. If that's a 9 and a 9, they're the same number, but they're not opposites. So they're not positive and negative of each other. So that seems like it would work, but it doesn't work. So it's not B. Oh, well, I guess I should check. If I multiply the second equation by 3, 8 times 3 is 24. 24 and -2 are not going to cancel out. Okay, that was good. What about C? Multiply the first equation by 3, then add. Okay, if I multiply this first equation by 3, this 9 is going to turn into a 27. That's not an opposite. This -2 is going to turn into a -6. -6 and 8 don't cancel each other out. Nope, so it's not C. What about D? Multiply the second equation by 3. So if I multiply the second equation by 3, and then, oh my goodness, then subtract. Dang it. Okay, so B is actually correct. I'm realizing that this, like, I was like, this says the exact same thing as B. This one says add, this one says subtract. Subtract means that we multiply everything by a -1, and suddenly 9 minus a 9 makes a lot of sense. Therefore, B is one of the answers. I have to read correctly, don't I? This part D is incorrect, though, because if you multiply the second equation by 3, this 3 turns into a 9. And if I add those, 9 plus 9 is 18. You didn't get rid of any of the x's. What about E? Multiply the first equation by 3, then subtract. If I multiply the first equation by 3, it turns into a 27x, a -6. None of those will cancel each other out, so E doesn't make any sense either. It should just be A and B. Number 12, solve the system of equations. We get to choose whatever we want. Unfortunately, this is kind of gross. We can't do anything. And I realize it's referencing lesson 7-4 where you're doing elimination. It makes sense to do elimination because our variables line up here and our numbers line up. Let's go ahead and do that. I'm going to choose to eliminate the x variables in this case because the numbers are smaller. Again, the best way that I can give advice on how to do these problems is to take the number from one of the equations and multiply that on both sides of the second equation. So I can say multiply the 2 down here on both sides and take the number 3 and multiply that on both sides of the other equation. That's kind of the fastest way to do these. So this could be multiplied by 3 on the other side, and that's not going to be enough because when I do that, this is going to turn into a 6x, that's going to turn into a 6x, but they have to be opposites of one another. One needs to be negative. So I'm going to randomly say, let's make this second one negative, and that means I need to make this a -2. Let's move you over here. So I multiply by -2. When I do that, let's go ahead and also, let's just color code this thing so it looks nice. All of this stuff, let's make this the color red. So for my red equation, let's go ahead and do that one first. I'm going to have a 6x plus, okay, I'm going to distribute the 3 over here as well. It's going to be 15y, and that's going to be equal to 15. For my blue equation, -2 times 3x is a -6x. It looks like these are lined up and ready to be canceled out. Distributing again gives us a -8y, and this is going to be equal to a +6. So now when I add my two equations, I should cancel out my x variable, leaving behind my y variable. It's going to be a 7y, and that's going to be equal to a 21. From here, we can divide both sides by 7, divide by 7, and y is equal to 3. We're halfway there. We have a y variable. We need to plug that in to find an x variable. It doesn't really matter which one you want to do. I guess I'm a little bit scared of that negative. Let's go ahead and do the first equation. So when I'm rewriting my red equation, I have 2x plus 5y y is equal to 5, and you know what I'm about to do. I'm taking that 3 and I'm plugging it back in for where my y was supposed to be. Multiplying these together gives us a 15. Rewriting the rest of this equation is 2x plus that 15 is equal to 5. Let's go ahead and subtract the 15 on both sides, and that's going to give us a 2x is equal to a negative 10. From there, we just divide both sides by 2, divide by 2, and x is equal to a negative 5. We have an x, we have a y. Let's go ahead and write that as a coordinate pair of negative 5, comma 3, and box it. Number 13, solve this system. So in this system, I am seeing that the variables are lining up, which makes me want to use elimination. I'm noticing that these t's would be really good candidates, except for this and this t are both negative. Let's make one of them positive. So I'm just going to randomly say the bottom one. Let's go ahead and make it a negative. So multiplying this entire bottom side by negative 1 makes me have a new equation, which I'm going to write up above so I can see what's going on. I have a negative r plus t is equal to a negative 1. Adding these equations together, a negative r plus a 2r is just 1r. These t's will cancel each other out because they are opposites of one another. So let's go ahead and cross this off. And I have a negative 1 plus 7, which is a positive 6, and r is equal to 6. We can plug that in wherever we want. I want to plug into this equation because it has the least numbers in it. So when I do that, I have r minus t is equal to 1, and my r is this 6 value that I will now plug in. So I now say 6 minus t is equal to 1. I'm going to subtract 6 on both sides, subtract 6 on both sides, and unfortunately I'm still left with a negative t, and that's going to be equal to a negative 5. I need to either multiply or divide both sides by negative 1. I like multiplying more. We can divide by negative 1. It's the same thing, right? Ooh, I wrote negative 1. There we go. And when we do that, I get a positive t, which is what we're looking for, and that's equal to a positive 6. So our answer is t is equal to 6, r is equal to 6. I guess I don't know if they're supposed to be written in any order, but it doesn't matter, does it? It's 6, 6. Which order did I write it in? I don't know. You tell me. All right. Number 14. It takes 3 hours to paddle a kayak 12 miles downstream and 4 hours for the return trip upstream. Find the rate of the kayak in the water. Let k equal the rate of the kayak in the water, and let c equal the rate of the current. Okay, so it says downstream, I get the current boosting me, so I get to go a little bit faster, so I'm adding the current. And when I'm going upstream, I'm going against the current, so the current is subtracting my speed. K is my kayak. I'm always going K. One of them is helping, one of them is not helping. And what are these T's and D? I don't know what's going on with the T's and D's. Oh, it takes time 3 hours versus 4 hours, but it's the same distance. You go the same distance regardless. One just takes longer to go that distance, right? And what are they doing over here? R times t. Well, r is k plus c times t is 3. So k plus c times 3, there's a 3 times that k plus c, and that's equal to the distance equal to the distance. Okay. So they kind of set up our equations for us, which is kind of nice. Those are the two equations. Find the rate of the kayak in the still water. So we're just solving for k in this case. So I'm going to rewrite this equation and distribute the 3 into both of these. So 3 times k is 3k, 3 times c is a 3c, and that's equal to 12. And I'm going to distribute the 4 into the k, so it's going to be 4k, and 4 times negative c is a negative 4c, and that's going to be equal to 12 as well. And then I get to decide what to do from there. Well, I see that my variables line up, so that makes me want to use elimination. Let's go ahead and multiply. I'm noticing that these are both positive and these are negatives of each other. They're opposites, so these are the ones that I want to eliminate. I guess it doesn't really matter. I'm going to multiply the top, this 4, by the top equation here and here. So let's go ahead and move all these over just a tad and say, okay, I'm going to multiply 4 by the top, 4 by the top, and that means this 3 is going to be multiplied here and here. So multiply by 3, multiply by 3 to get some new equations. So our new red equation is going to be, I guess I can write it to the right hand side. I got plenty of room over here. My red equation is 4 times 3k is 12k. 4 times positive 3c is a plus 12c. And that's going to be equal to 4 times 12, which is 48. For my blue equation, distributing the 3, that's going to give me 12k. And then 3 times negative 4 is negative 12c, and that's going to be equal to a 36. And now I can add these straight together, and these 12c's should cancel each other out. So when I add these together, you're gone, you're gone. Adding together gives me a 24k here, and that's going to be equal to, what is this going to be? 6 plus 8 is 14, carry the 4, and that's going to be 84. Nice. And then from here, I just need to divide by 24, divide by 24, and I get k is equal to, and by the way, before I even get k, I'm noticing that I just want to find the rate of the kayak. I don't need to know the stream. I don't need to solve for c, so I got lucky. I don't have to do the second half of the equation. I just need to do k. So now coming back here, the answer is this fraction of 84 divided by 24, but what is that? Because I can divide the top and bottom both by some number, right? Let's see. Can I divide both of them by 6? I think I can. Does 24 even go into 84? It might. Times 3. No, that turns into a 12. Let's just try dividing both the top and bottom by 6 for now. I think we can probably divide by 12. Can we divide by 12? Here, I want to try it. Divide by 12, divide by 12. I know the bottom is nice because that turns into a 2. The top is 84 divisible by 12. I want to say 7 times 12 is 84. Let me just double check that just in case you don't know. It's 12 times 7, I think, is 84. So 7 times 2 is 14, and then 7 times 1 is 7, plus the 1 is 8. So 84 is indeed correct. So I'm going to say that this is really 7 here. So 7 halves. The answer is 7 halves. If you prefer a decimal, you can say that's the same thing as 3.5. We probably should have had units on this. What is it? So it's miles an hour, so it's miles per hour. So the answer is 7 halves miles per hour. You can write mph on these if you want. You don't need units though. Miles per hour. I was just curious what that is. All right, number 15. We've got some graphs. Cool. In what region is the solution set? Well, the solution set is wherever we have the shaded regions cross over. So this is one of the shaded regions. This is the other one of the shaded regions. And notice that it's darker in this quadrant D. So the correct answer here is D. It's where the shade overlaps. Nice and easy. Number 16, which graph represents the solution of these guys? So what do I know? Like whenever I have these questions, I always look at what are the differences between these. Some of them, like I see a dashed line versus a solid line. It's the same dashed line, solid line, dash, dash, solid, solid. We should be able to eliminate some of these. I'm noticing I have an equal to sign and no equal to sign, which means we should have one dashed, one solid. These are both dashed, which means it can't be C. These are both solid, which means it cannot be D. It's between A and B because it's a mixture of a solid and a dashed line. And I'm noticing that the difference between A and B, they're the exact same dashed, exact same solid. The only thing that's different is which shaded region is correct. So let me do a simple test point. I can test at this point down there or this point over here. There's not really a good lattice point or a point in the crosshairs down here to test. So let me go ahead and test, I don't know, any, like at that point, that point, that point, any of these crosshair points, they're called lattice points. I really like plugging in something that has a 0 in it. So plugging in this number is going to be my favorite one. So that's the number I'm going to plug in. This coordinate point, by the way, is 1, 2, 3, 0, 3, 0. So that means my x coordinate is 3, my y coordinate is 0 when I plug these in. And this should solve for this and for this. Let's go ahead and test, shall we? So for the first one, in fact, wait, do we need to test both of them? So I'm noticing that it will always, so if I have this shaded region and this shaded region, that's where it matches up for this area. So I'm trying to see, do I need to plug into both of them? I think we can be a little bit smart about this. So I'm noticing that regardless of the line, like it's always going to be shaded on the bottom half. I think you guys can both agree this shaded region and this shaded region are both underneath or to the bottom right of the solid line. So plugging it into the solid line is not going to be revealing. It will always work, but notice the difference. One of them is shaded on this side and the other one is not shaded on that side. So plugging it into the equation with this dashed line is going to be the one that will reveal it to us. So I really want to plug it into that one. That's the really big difference here. So that's being clever, not plugging it into both. Although me explaining that probably took as long as just plugging it in, didn't it? All right, so 2x plus y needs to be greater than -3. So my x is a 3. Again, 3 is plugged in right here, and my 0 is plugged in right here. So I wrote those lines, and I need to multiply these together. 2 times 3 is 6 all the way down here, plus 0 needs to be greater than -3. Is 6 greater than -3? Well, a positive is always greater than a negative, so this is true, which means it needs to be in the shaded region. Notice that this point right here is not in the shaded region, but it needs to be true. Therefore, the correct answer here is just A. Nice. Number 17. Diana wants to build a rectangular pen for her goats. The length of the pen. Okay, I already need to draw a picture. I have no idea what's going on here. So it's a rectangular pen, and I happen to know that rectangles look basically like that. Let's go ahead and make that look pretty. Thank you. Oh, that's a trapezoid. It needs to be parallel, 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 parallel. Can that be a trapezoid? Okay, it's not trapezoid. Hooray, it's a rectangle. Okay, I have a picture. The length. I'm going to go ahead and call this thing right here the length. The length of the pen should be at least 50 feet. So 50 or more. So at least 50 feet. And the perimeter of the pen should be no more than 90 feet. Oh my goodness. Okay, so if that's the length, I'm going to call that variable L because I'm lazy. And I'm going to call this the width. And I'll call that variable W. So how do I find the perimeter? So I know that perimeter is this plus this plus this plus this. Just add all 4 of the sides. So if this length right here is the length, this is also the same length. If this is the width, this is also the width. So the perimeter in this case is equal to, I need to give myself some room. The perimeter is going to be L plus W plus L plus W. It's going to be L plus W plus L plus W, and adding my like terms, L plus L is 2L, and W plus W is 2W, so the perimeter is 2L plus 2W. This perimeter, the perimeter can be no more than, it can be equal to, but it can't be over 190. So it has to be less than or equal to 190. So here's my first of my 2 equations. I don't know why I boxed that, but it's an important equation. The other equation is this one. Length should be at least 50. So the length should be at least 50. So it can be greater than or equal to 50. Here are the 2 inequalities that I need. What is a viable solution for the dimensions of the pen? This one is interesting. How would I go about solving this one? So I'm realizing that in the multiple choice, all of these numbers 29 are all the same number. And one of the equations, or I guess I didn't really need these equations, did I? You could have just used logic. I guess I can come back and show how I would use these equations at the very end, but I don't think I needed any, like, I could erase literally all of this stuff and I would still be able to solve it. Because if the length has to be 50 or more feet, can that be the length? No, that has to be the width. So we know by default, this has to be the width. The width is 29 feet. This is the length. So the length has to be at least 50. Is that number at least 50? No, it's not A. Is that number at least 50? Okay, it could be B. Is that number at least 50? Okay, it could be C. Is that number at least 50? No, it's not. So A and D are eliminated because neither of these numbers are greater than 50. And we know that one of the dimensions has to be at least 50. So which of these is a number that we're looking for? So we've kind of used up this equation that length has to be greater than 50. Now we are going to use this fact that we need to be under a certain amount. So if we know that the width here is 29 feet, we can actually say that 29 goes into this width length right here. We can say 2 times 29 is 58. And we can rewrite this equation. We can say 2L plus 2 times 29 needs to be less than or equal to 190, and I can multiply those together, so I get, what is this going to be, 2L plus, I already said, 58 needs to be less than or equal to 190, and from there, I'm going to subtract 58. That means 2L is going to be less than or equal to, it's 132. Just to show you what I did in my head, I didn't do 58 because that's too hard. I did 60 because 58 and 60 are really close to each other. So I did 60, 90 minus 60 is 30, but then you have to go 2 back up because I did too many. So 132, and then divide both sides by 2. Ugh, gross. It's not a fun division problem. Divide by 2, divide by 2. Therefore, L has to be less than or equal to, what is this going to be? Well, again, here, let me show my work this time. 132 divided by 2 is the same thing as, okay, I don't know what 132 divided by 2 is, but I happen to know what 120 divided by 2 is because 12 divided by 2 is 6. Add the 0 on it, and it's 60 or 60. And the problem with this is 120 is not 132. So to get from 120 to 132, I need another 12 more. So plus 12. And you have to have like denominators, so it's over 2. Just check it out. 120 plus 12 is 132, and 12 divided by 2 is 6. So we'll do a 6 up here, and 60 plus 6 is 66. So that means that the length, the other number, has to be less than or equal to 66. Well, this number is greater than 66. This number is less than 66. So that means C is a viable solution. So that's like a mixture of using logic and equations. I guess you could use pure equations, plug 50 in for L, pretending this is an equal to sign, but that still doesn't give you the 29 over here. So the mixture of logic, 17 was a really tricky problem. And that does conclude the practice test, because that is page 6 out of 6. So we are done with the practice test. Did I get them all correct? I'm not sure, but I did my best. So that concludes our practice test. Let me scroll back through these so you can see all the answers that I got. If you find a mistake that I have made, you get extra credit. So please be making sure that I have made no mistakes. Let me know if I have. Thanks for watching.